Three, two, one, action. What's up, everybody? I am here. We are going to be going through the 2018 FRQ number 5. I would say it's a really interesting function that we're going to be looking at with this FRQ. The parts are pretty reasonable, mainly focusing on applications of derivatives on this function. Part D is really fun because it throws in a little L'Hopital, which is one of my favorite parts of calculus because I think it's really beautiful. But we are going to go ahead and get started on question number 5. So let's go ahead and dive in. Part A. So the first thing it tells us is it says let f be the function defined by f of x is equal to e to the x times cosine of x. So that's the first thing I'll write down. Obviously going to be important. Part A asks, what is the average rate of change of f on the interval 0 to pi? Now we have to be careful. Average value and average rate of change are very different things. But average rate of change is just going to be our final value minus our initial value divided by our total distance traveled. In this case, it'll be the length of the interval. So thinking about the final and initial values of this function, we are going on the interval 0 to pi, as it tells us in part A. So the average rate of change from 0 to pi would be f of pi, which would be our final value of the function, minus f of 0, which is the initial value of the function, divided by the length of the interval, which is just pi. So now we can calculate these values. F of pi is e to the pi power times the cosine of pi. E to the pi looks pretty weird, but it's actually just a constant, right? Because those are two constants. The cosine of pi is -1, so f of pi becomes negative e to the pi power. Now, f of 0 is a little bit different because when I do f of 0, I get e to the 0th power times the cosine of 0. E to the 0th power, it's still a constant to a constant, but any constant raised to the 0th power is just 1. So this will give us 1 times the cosine of 1. The cosine of 1 is also 1. So f of 0 is equal to 1. So now plugging these values in for our formula, we get negative e to the pi power minus 1 divided by pi, which is a super ugly answer. It's a little bit scary answering an FRQ and getting an answer like this for a question, because it really makes you question, like, did I do this right? Am I looking at it wrong? But in this case, it is just an odd answer. So this is our answer to part A for the average rate of change of this function on the interval. So that's part A, not too bad. Ugly answer, but the work was not especially challenging, I feel like. Now, part B, we have another application of derivatives. And in this case, it's talking about slope of tangent lines. So part B says, what is the slope of the line tangent to the graph of f at, I'll write it down, x is equal to 3 pi over 2. And just to remind you of our function, f of x is e to the x power times the cosine of x. So in order to find the slope of a tangent line, we know that that will be represented by the derivative of the function at the point. So the first thing we need to do is solve for the derivative of the function. Now I have e to the x times cosine x, so this is one function multiplied by another function. So we're going to use product rule. Product rule tells us that our derivative is the first term times the derivative of the second term, which in this case is negative sine x, plus the derivative of the first term. E to the x is a really special function because its derivative is itself. So it's just e to the x times the second term, which is cosine of x. So now we have this expression for the derivative or the slope at any point x, right? So now I can plug in 3 pi over 2. So f prime of 3 pi over 2 will be e to the 3 pi over 2, which is really ugly, once again, times the negative sign of 3 pi over 2, plus e to the 3 pi over 2 times the cosine of 3 pi over 2. Now we're going to get a little bit lucky here, and that is because of these cosine values. Once again, just like part A, we have e raised to another constant, so that's just going to keep its same value. But these trig functions, the cosine of any pi over 2 value is equal to 0. Because if I were to draw a little mini unit circle, right? It's not a great circle, but we know that cosine is represented by the x values. And my angles, they go 0, pi over 2, pi, 3 pi over 2. Well, at this point, 3 pi over 2, which is what we're solving for, our x value is equal to 0, and our y value is negative 1. So this means that sine of 3 pi over 2 is negative 1, cosine is equal to 0. So plugging these in, I get e to the 3 pi over 2 times negative 1 plus e to the 3 pi over 2 times that cosine of 3 pi over 2 is just 0. So that whole term just goes away, which is really helpful. Now for this first term, these negative signs cancel out, and we are just left with e to the 3 pi over 2, which is our derivative of the function at 3 pi over 2, which represents our slope of our tangent line at the point. So once again, an ugly answer. I guess that's just a theme of the question, but still shouldn't be much of an issue. Biggest first step is taking the derivative of f of x, using product rule to solve that, using some unit circle in between. But that is part B. Now, part C, I think, is the most difficult part of this question. And I think part of it is just due to the number of steps, right? So part C, it asks us to find the absolute minimum value of f on the interval x is between 0 and 2 pi. So I'll write down my function again, just so we don't forget it. You guys probably have it right next to you, though. Our interval is now 0 to 2 pi, whereas in part A, it was just 0 to pi. So we need to find the absolute minimum. Now, absolute extrema, we know only occur at relative extrema or endpoints. And the way that we find that is by using our candidates test, right? We'll find our relative extrema, we'll find the endpoints, and we'll plug in these values and see which one gives us the smallest value. So let's plug these in, right? If I were to find, before we do that, let's find the relative extrema. Now, we know that relative extrema occur when our derivative is 0 or undefined. I'm going to take a peek back at part B and just copy down our derivative that we took in part B. It was e to the x times negative sine of x plus e to the x times the cosine of x. And we are trying to see where this function is 0 or undefined. Now, these two terms are kind of separated right now. To combine them, I might factor out an e to the x power. And that would leave me with cosine of x minus the sine of x. Now, this cannot be undefined because e raised to any real power is a real number, and cosine and sine are also defined for all real numbers. So, it can't be undefined. It can equal 0. But one important thing is that e to the x, moving it around, e to the x cannot equal 0. And that's because any positive number, which e is, right? It's just a constant. Any positive number raised to a power will not equal 0. It will always be greater than 0. So our only remaining option is that the cosine of x minus the sine of x is equal to 0. Cosine of x is equal to sine x. So we're looking over the interval 0 to 2 pi. So how many possibilities are there? I'm going to draw that mini unit circle again, as poor as my circle may be. That one was a rough one, I'm sorry. But sine and cosine are equal to each other at 2 points. One right there and one right there. And those points are pi over 4 and 5 pi over 4. These are the points on the unit circle. At pi over 4, sine and cosine are both root 2 over 2. At 5 pi over 4, they're both negative root 2 over 2. So, looking at these values, I know my critical values are going to be x is equal to pi over 4 and 5 pi over 4. Those are my critical values. So now that I have my critical values, I need to do a test. For me, I would much rather do the first derivative test, because taking the second derivative would be absolutely appalling. So doing my first derivative test, I'll set up my critical values on the number line, and I need to plug in some points. So if I were to plug in something greater than 5 pi over 4, let's say I plugged in 3 pi over 2, which would be represented right here on the unit circle. Cosine is equal to 0, sine is negative 1, so cosine minus sine would be positive. And e to the x is obviously always positive. Now between pi over 4 and 5 pi over 4, I could plug in pi. The cosine of pi is negative 1. The sine of pi is equal to 0. So negative 1 minus 0 gives us negative 1, which is a negative value. And finally, I would need to plug in a value less than pi over 4. I would want to be careful, but I could plug in 0 because 0 is a part of our interval. Cosine of 0 is 1. Sine of 0 is 0. So I'll get 1 minus 0, which is 1. So it gives me a positive value. So our function is increasing from 0 to pi over 4, 5 pi over 4 to 2 pi, and then decreasing between pi over 4 and 5 pi over 4. So our relative minimum, which is what we're looking for, right? We're looking for minimums. It will occur at 5 pi over 4, because that is where the function goes from decreasing to increasing. So 5 pi over 4 is our value. So I'll write that down. X equals 5 pi over 4 is our relative minimum. In the same way, pi over 4 would be a relative maximum, because as we go from an increasing to a decreasing function, pi over 4 is a critical value, and it will be the peak of that mountain. So now we have our relative minimum, and we need to use our candidates test in order to find the values. I'm going to use a different sheet of paper just to keep this nice and clean for us, but I'll write down the important information. So part C, continued. Our important information is this. F of x equals e to the x times the cosine of x. Our interval is from 0 to 2 pi. We're looking for the absolute minimum. The relative minimum is at x equals 5 pi over 4. So now we're just going to compare the f value of all three of these values, the endpoints and 5 pi over 4. So I'll need to solve for f of 0, f of 2 pi, and f of 5 pi over 4. F of 0, if I were to plug it in, is e to the 0th power times the cosine of 0. E to the 0th power is 1. Cosine of 0 is 1. So f of 0 is just 1. So really easy to compare to other values. Now f of 2 pi, if I were to plug it in, it's e to the 2 pi times the cosine of 2 pi. Now e to the 2 pi is just a constant, right? Cosine of 2 pi is the same thing as cosine of 0. It's just 1. So you'd get e to the 2 pi, which is like e to the little bit greater than the 6th power. So this is a really big positive number, probably the absolute maximum if I had to guess. Now, f of 5 pi over 4, this is our final one. It'd be e to the 5 pi over 4 times the cosine 5 pi over 4. From our unit circle, we said the cosine of 5 pi over 4 is negative root 2 over 2. So this will be e to the 5 pi over 4 times negative root 2 over 2. Or, I could write this as, one value. Maybe I write negative e to the 5 pi over 4 root 2 over 2. And that, clearly, as the only negative number between these three, is going to be the relative minimum for f. Reading the question carefully, because we want to make sure it doesn't ask for the absolute minimum. What is the x value? That would be 5 pi over 4. It asks for the value of the function, giving us this answer. It also asks for justification. I would say something along the lines of using the candidates test. We see that comparing, right over here, comparing the value of f at relative extrema and endpoints that f of 5 pi over 4 gives the smallest value. And that is probably even more winded than you needed. You could probably just say, using the candidates test, it was determined that f of 5 pi over 4 was the smallest of the candidates. And that would probably be enough, but if you can write more, why not write more? But definitely say candidates test. That's what the AP is looking for, right? That you know your verbiage, know your vocab. But part C, tough part, long-winded, a lot of steps. I probably took longer than it would take you guys to actually do it if you were working on it. But I wanted to go in depth through it, so there were no hiccups for you guys as you review it. But moving on to part D, which I really love. I already said this before. It's a L'Hopital question. I'm a big fan of L'Hopital, a L'Hopital enjoyer, some might say. But it tells us g is a differentiable function such that g of pi over 2 is equal to 0. It says the graph of g prime, the derivative of g, is shown below. And it asks us to find the limit as x approaches pi over 2 of f of x over g of x, or state that it does not exist. And it asks us to justify our answer. So, to solve for a limit, the very first step of any limit question is using direct substitution. So this limit will be equal to f of pi over 2 divided by g of pi over 2. I'll write down our function f again. F of x was e to the x times the cosine of x. So f of pi over 2 is e to the pi over 2 times the cosine of pi over 2. And g of pi over 2 tells us is 0. Now, e to the pi over 2 is just a constant, but the cosine of pi over 2 is equal to 0. So we get that when we direct substitute that our limit is 0 divided by 0, or is an indeterminate form. So that doesn't mean that the limit doesn't exist. It means we just don't have enough information yet. And one rule that we learned that is very, very helpful for us in these types of situations is L'Hopital. And L'Hopital tells us that I can take the derivative of the top and the bottom of this if I'm in indeterminate form, and that limit will be equal to my initial limit. So the limit as x approaches pi over 2 of f of x over g of x will be equal to the limit as x approaches pi over 2 of f prime of x over g prime of x. Now, f prime of x, we'd have to, flash back to, I think it was part B. We were dealing specifically, and part C. We were dealing with the derivative of f prime, or the derivative of f, which is f prime. But we're going to do our direct substitution step again. So this would equal, f prime pi over 2 over g prime pi over 2. I'm going to do a little callback to part B, where we wrote out our derivative, use that once again for this question. So f prime of pi over 2 would equal e to the pi over 2 times the negative sign pi over 2 plus e to the pi over 2 times the cosine of pi over 2, all divided by g prime of pi over 2. And we can solve for that using the graph of g prime that they give us. Now we look at the graph and we see, oh, okay, so at pi over 2, there's a sharp turn. So our derivative would be undefined, right? But we need to be careful. That's a graph of g of x. And g of x at pi over 2 is equal to 2. It has an actual value. The second derivative of g would be undefined. So we gotta be careful of that. But now, looking at this, cosine of pi over 2 we just said was equal to 0. So that whole second term will just be 0. This first term, the sine of pi over 2 is equal to 1. So I would get negative 1 times e to the pi over 2 divided by 2. And because that is not in a form that is 0 over 0 or some number divided by 0, this is the value of that limit. Which once again, we've basically gotten 0 friendly answers throughout this entire test, which is or this entire question, which is a little bit tough. It's 2018. I think they rolled with a lot more ugly answers back then. But this would be the value of the limit. So, overall, I would say a challenging FRQ. A, B, and to be honest, D, I felt were very reasonable, very doable. Shouldn't have been much of an issue. Part C, I think, could have definitely been a time waster for a lot of people because you can spend a lifetime doing the candidates test. So, maybe all you do is like you find the relative extrema, you get yourself a point, and you move on, save yourself some time, whatever you need to do to finish all the questions. But that is all we got for now. I'm sure I will be talking to y'all soon about more calculus. But hope you guys have a lovely day. Adios.